Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside these live shows, so toss me a buck or two in there if you are enjoying these debates. But most importantly, if you would like to join the debate with the page you are currently listening to on mute, simply click the link in the info box below this video to join the discussion and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you'll be ejected, and if you are, please do not try to rejoin using sock accounts. You'll be warmly welcome back on the next stream. With that, I'm going to transition across to my photograph so I can share the show on social media, and I would encourage anybody who is in the live audience to please also share the show. Sharing, of course, increases the live audience, but this in turn increases the chances of having a more diverse panel, so please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. So I've just shared the show on Facebook, Skype and Twitter and double checked that we do actually have a working link, and it seems that we do. However, if somebody who is in the live audience now could just click on that link just to check that it is all functioning correctly, I'd be very grateful. Make sure it's all working fine, and in the meantime I'm going to do a few shout outs to the people who've joined us already. So Dunning Kruger, good to have you here, nice to see you, thanks for being in our live stream. What boy, Marlene, good to see you. The Rig, good to have you here. Thanks for being here. Nice to see you. Flatman, good to see you in our live chat, my friend. Morky Love, big heart to you too. Thanks for being here. Be sure to share the show. Flat World Takeover, click that share button, my friend. Thanks for being here. Agent Detective, says Savaloy. Indeed, no idea what you're talking about, but good to have you here, Agent Detective. Thanks for being here. Stopping traffic in my mega hat. Thanks for being here. Good to see you. Baz. Thanks for being in our live stream. Good to see you, my friend. Hyena Earth says, good morning, Flurfers. Good morning to you too, Hyena. Roger MC, thanks for being here. Nice to see you. Jeff says, I see it. Hopefully he's talking about the link. Sean G, nice to see you, my friend. Thanks for being here. Gary Heather. Hello there, Gary. Good to have you. Captagenen. I think I'm saying that right. Good to have you here. Thanks for being here. Any more for any more? I think that's pretty much it. So I'll run through my links one more time, as these shows do tend to kick off a bit more quickly than they used to. So if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live. And if you would like to join the debate with the page you are listening to me on now muted, simply click the link in the info box below this video to join the show and express your views on the shape of the Earth. There are a couple of rules. Number one, don't swear. If you do, I'll kick you out. And if you are kicked out, please don't try to rejoin using sock accounts. You'll be warmly welcome back on the next stream. So if you've not done so already, share, subscribe, hit the bell, and I'll see you with exactly the same information in a few minutes' time if we're not joined by our first guest. Good to have you here, Lottie says. Nice to see you. Good to see you, Make 4. Thanks for being here. Nice to see you, Boddy. Morning to you, Sue. It's usually ranty or sleeping warrior that takes advantages of these calm little moments on these morning shows. Yeah, for those in the know, obviously were you to join now, you'd have the platform to yourself to express your opinions unchallenged. What you got there? No, no, don't touch that. No. That's not yours, is it? Thank you. Look at all these lovely toys you've got to play with. You don't need my phone. There you go. You soundly fans in the audience, it would seem. Orb Sweeter says, no fair, it's too early to debate in America. I can't say it like Dale. In America. America. Do I drink gin and tonic? I have been known to drink gin and tonic in the past. I'm not a big drinker, to be honest. I don't drink very much at all. Maybe once or twice a year at the most. Brandon Cook says, hello Nathan, hello all, what a wonderful world we live in. I have just suddenly grown a beard. That's lovely, Brandon. Thank you for letting us know. Thank you for sharing. New studies suggest that gin and tonic drinkers are more likely to be psychopaths. Called it, says Captain. Can't read it that length. Let's look on the iPad. Captain Agennen. Captain Agennen. Is that right? I'm pretty sure psychopathy has everything to do with the lack of empathy and nothing to do with gin and tonic, I'm afraid. Hi, Vane Veen. Says hi from Australia. The Ashes test is over. 4-day rained out. Oh, day 4 rained out, sorry. Another thumbs down from Michael. It's fine. Couldn't care less about thumbs up or thumbs down. YouTube don't use it to place your videos in the stats anymore. Meaningless. Yeah, shortly before the adpocalypse, as it's been dubbed, YouTube changed their algorithms. So previously they went on views, likes, comments. Now they don't. I mean, I'm sure they are still part of the algorithm to a certain degree, but all YouTube are now interested in is watch time. That's literally all they're concerned with. For obvious reasons. You know, they want people to spend the most time on their website. The more time spent on their website, the better. And that directly translates into YouTubers like myself and their statistics for watch time. So yeah, thumbs down all you like, I couldn't care less. Literally doesn't make any difference. Where are your guests? I don't know. This has been probably the longest gap. Well, we've got 15 minutes already streaming. No guest. Better make it 4 hours then. I don't think so. If the whole show was me sat here just jabbering about YouTube stats, easy life for me. I'm not fussed in the slightest. There'll still be another show later. Everyone's sick of the Isle of Man bullshit. Oh well, tough luck. I'm more than happy for Ranty and Sleeping Warrior to keep banging that drum indefinitely. It is a sensational piece of flat earth proof as far as I'm concerned. Even after the globeheads fudge the figures on it, they still don't bring things that should be behind the curve back into view using their maths. The only way they can do it is breaking down the refraction formula, altering it, making it more extreme to make those mirages go that little bit further. It sounds beautiful. That's a beautiful, beautiful drum that they have there, the rig. Nice that they let me hit it occasionally. Lol, Riley doesn't have his figures. I don't know what you're talking about. Baz. Loads of figures on screen. Ah, Cat Earth. How you doing, Alex? Has the penny dropped? Will I get a 9th attempt at explaining it to you? You very angry? Let's hope so. Keeps me amused. What about this 1,300 foot wall? What's there isn't? First guest, thank God. How you doing, Tony?
How you doing?
Good to see you.
Thought I'd jump on. I didn't sleep much. So, Nathan, we haven't talked yet, have we? How's everything going?
Everything's cool, man. No changes here.
Last night was a little... I don't know, man. You really felt good about what happened last night?
Oh, it was a proper pain in the ass. Someone dropped pornography into the stream, so I had to spend 3 hours editing it out. Just a pain in the ass.
No, not that. I understand that. That's understandable. I'm talking about the way you treated Stanley.
After he lied to me.
He didn't lie to you.
I asked him a very direct question, and he gave an answer that was very specific. See, I'm quite careful with the way I phrase things, you see, Tony.
I know, I've noticed, because you like to get people in gotchas. And you'll use someone else's question as a platform for your gotcha. They'll answer their question, and you'll...
Yeah. You're
That's
so,
exactly
you're so
it.
careful with everything you say. You manage to contradict yourself 3 times a day, a show. You manage to... we can, like, I mean, literally, we're going to put a video together just to show you one day, Nathan. It'll be a great advert for what you are. It's going to be
I think
insane.
maybe you've just been in the...
You don't listen back to your streams, Nathan. That's what's funny. They're hilarious, the things you say.
Yeah, it is. I would say that.
Do I get it? Do I get it? Oh, we're going to get you for the 3rd time. It's like, nah, you're not, Nathan. You're just going to make yourself look like an idiot for the 3rd time. So, yeah.
I mean, if your like goal is to have like a Jerry Springer type flat Earth show, then you're doing great. I mean, this is wonderful.
Oh, that is his goal. But I mean, Jerry Springer doesn't come off looking like the biggest moron on his
Yeah,
own show.
he's nice.
So that isn't what he's going for.
I mean, it's just like Stanley brought the evidence that he brings all the evidence.
Nathan saying, "Oh, I'm enjoying everyone being triggered," but the reality is most of us are fine, Nathan. I didn't have to spend 3 hours editing the porn bomb out of my show yesterday, and I'm not the one who stooped so low to start calling people snivelling worms over one little tiny one. Yeah, that was so triggered over the tiniest little point where you're saying because at the end of the day, that isn't really under sea level, is it? It dips. You know, it dips below sea level with the tide. But I mean,
like 3 times out of 365 days.
Right, so it does go below sea level, which was my question that he gave no answer to.
It dips, but originally, Nathan, it's below sea level, and then it goes below sea level.
3 meters below sea level. That was the original question.
My question was, does it go below sea level, yes or no? My question was really clear. He gave a no answer.
I understand that.
A few seconds later, it went from yes. It went from no, it doesn't go below sea level to, well, maybe it goes to low sea level to him actually providing the proof that it went below sea level.
Yeah. So
and he corrected himself.
How is that anything like the way you guys act, where you actually deliberately don't obfuscate and you don't show things?
Yeah, then he claimed ignorance. Then he claimed he didn't know. So what he claimed, Alex, was I didn't know that. So when I asked him a direct question, does it go below sea level, and he said no, he actually didn't know.
You asked him, is it below sea level now?
Right, well, he had the data.
Yeah.
He had the data, though, didn't he, Alex? He had the data, and the data showed him that it went below sea level. He showed him that.
And then you went on and
you guys didn't even know he had the gauge. You guys didn't even know they had that
sniveling worm for
yeah, because he lied. I'll call him it again if he lies again. I'll call him that for lying. That's why I called him it, Alex, because he lied. If you lie to me, I'll call you a worm.
Wait. I mean, how about Ranty? Ranty lied deliberately right to us.
Yeah.
And then you backed him up on it, Nathan. That was a lie.
Riley lies constantly. Do you still think you can't measure angular size, Nathan? Do you still believe that? Or do you still back in Riley? That it's not possible to measure angular size at the observer's point where the angle is created? You see what I mean? You guys are the worst. You're the biggest hypocrites, man. I love the fact you're recording all these shows, man. It just gives us plenty of time to edit it all together and just make you look ridiculous.
Well, let's hope somebody edits me asking Soundly a very direct and specific question about whether or not Pontchartrain goes below sea level. And him, hold on, why do you keep, every time I talk, both of you talk over me, and I'm getting a bit sick of it. Can you both stop talking over me? You're asking me direct questions and I'm answering them. If you don't like my answers, Alex, just don't talk over me, Alex. There's no need. No need.
I don't want you to answer. I want to talk about you on your show to Tony. You're the moderator. Sit back and listen.
Sit back and let you slag me off, Alex. Alex, I'll slag you off. You're a moron. It's taken 9 attempts for you to understand that there's a 1,000-foot wall in the way of your model. You haven't understood that, and it's taken me 9 attempts. So if you think I'm just going to sit here and let you slag me off on my own show because you think that you can position me as a moderator, Alex, you're wrong.
And I'm going to make you break your rule and kick me off your show without swearing. Just to show more what a hypocrite you are.
Oh, right. Is that what you think, Alex?
Because when you sit there and say, oh, I'm not...
A moment ago, you just told me that I'm a moderator and I'm going to sit here and listen to you slag me off.
Yes, you're going to have to, yeah.
No, I'm not. I'm going to sit here and point out to the audience that you're a moron and it's taken me 9 attempts. Yet even on yesterday's show, I asked you if you understood if there was a 1,000-foot wall in the way, and you said no. No, there's not a 100-foot wall in the way. That's because, Tony's piping up now. Now I'm jumping down his throat. Yeah, it is a wall.
Nathan.
Yeah, it is.
Construction. It's not even a wall.
Yeah, wall. Wall of Earth.
It's not even 1,000.
A wall of Earth. Anyway, we've got a new guest. Sorry, Alex. Bear with me. Bear with me, Alex.
You call that a wall?
Bear with me, Alex. I know you're very angry about this wall. Come to help. Anyway, let me introduce our new guest. How are you doing, Jeremy?
Yeah, please do.
I'm good, thank you. I have a quick question, Nathan, if I may.
Okay.
When Ranty asserted that it was 3 to 7 meters below sea level, was he correct?
Answer the question, Nathan. Come on. Go all quiet.
You see my screen?
No, answer the question.
Can you see my screen?
Now you...
Yeah.
Can you
Can you see where it says? Can you hold on? Can you? You're doing it straight away, Alex. You've asked me a question. I'm answering it, and you're talking over me immediately.
Okay, go ahead. Go ahead and answer it.
Can you see what it says on screen?
No.
No, I can't read it.
You see where it says minus 12.54 feet? Can you see that?
No.
Yeah.
I'll
What
tell
is
you
it
where
that we're
this is,
looking
though.
at then?
Can you see
You
what
found
is
a
on
place in
screen?
Louisiana. You found a place in Louisiana that's 12 feet below sea level?
It says Lake Pontchartrain.
Right.
Right, here we have.
So that's one of the days then, huh?
Right, this is just
But
bits
it
of
says
data.
Lake-
Hold on,
it says Lake
hold on.
Airport.
This is just bits
So-
of Soundly's data that he didn't bother presenting to you. Does that answer your question?
What's relevant about it for a start? But sorry.
Does
like
that
to-
answer your
Can you
question?
link that in the
No,
side
it
chat?
doesn't. No,
Sorry,
it does
sorry,
not answer my question. It does
No, it
not
doesn't.
answer my
Yeah, it
question,
doesn't.
Nathan, at all. So I'll ask the question again. When Ranty said it's below sea level by 3 to 7 meters, was he correct?
I've just shown you that it dips below sea level by
answer the
12
the
and a
answer to the
half
question
feet.
is either yes or no. It's not, here's a diagram. Was he correct or was he not correct?
It certainly seems to be the case that he was correct. It certainly seems to be
Right,
showing
so
that
you're
it's
saying
measured.
he was correct when he asserted that the basin lay 3 to 7 meters below sea level, or I can't remember the specific words.
Yeah, it was
Because what
basically.
you're showing us here, I mean, I don't know specifically what you're showing us here, but what we're seeing is a very, very sharp dip. So something that happened over a short period of time. If that's a year, that's probably a day.
It's over
you know.
about 11 hours, which is very suspect. But there we go.
Right.
There's now 2 pieces of evidence that show it about 3 meters or whatever, 13 feet.
that
Whatever.
does not show that, does it? That shows, you know,
11
something
hours.
temporary that happened on one day. And because
Yeah,
of the anomalous nature of that data, we need to know what causes that.
I agree.
You know what the cause
In
of
no
that?
way would you say that it's 3 meters, because that makes it sound like every day is 3 meters below, not
Exactly.
just one arbitrary hour out of the year. It all of a sudden was 12 feet below sea level. Obviously,
But-
something happened.
But if you're drawing on that data, all we need to do is check the data for the day when Soundly was there and see if there's a 3 meter dip or whatever you're claiming.
I'm not claiming anything. I'm not claiming
and then
anything,
we
just
can
to be clear,
determine
Jem.
from that if there's an issue.
I'm not claiming
But-
anything. So, Ranty presented evidence from the USGS, and I read it. That's what happened.
Right, but what he presented is a different thing to what Soundly presented, and you're pretending they're the same thing. And if you think they are, you've either misunderstood or you're just obfuscating the evidence yet again, Nathan.
Maybe I'm not claiming to fully understand this. All I'm
Because he
doing is
was talking
presenting
about the
what I have been
topography of the
shown
land,
so
and
far,
You're
Jem.
talking about a little tidal dip. Sorry,
Right,
sorry.
I've said it
Go
looks
ahead.
suspicious.
Well, it's funny that you don't.
I've said it looks odd. I said it needs more investigation. I'm not obfuscating at all. I agree with
Put
you.
them down, but you don't fully understand it. Yeah, okay, that's a sensible course of action to take in life. Oh, and why don't you live stream it to hundreds of people at the same time, so we can all remember it forever? Very clever.
And this evidence, this video evidence, is coming out to light that it's fake, because Anthony won't even give us the raw data. Not like every other experiment, a person that does experiments, they always give the raw data. Anthony, for some reason, isn't doing it, and I think I found why. It's in the video. You can clearly see it.
How you doing, Lottie?
Do that.
Can I just say hello to Lottie? How you doing, Lottie? Can you hear us?
Good morning, everybody.
Good to have you here.
Morning.
Nice to see you.
Has anybody seen Ranty around? I'm here to collect my money again.
Yeah,
Yeah,
there's no lie.
he bet us £5,000. Well, he bet Lottie £5,000. Well, actually, he bet everyone £1,000 each, and Lottie took all 5 because he was smart like that.
It's not like that the last 2 videos he made weren't frauds, and this third one's a fraud too. And I don't know, Nathan, if you are all on board with this or are you just like blind to it, but it's obviously there's something wrong with it.
I think
And-
that's a good question. Are you in on this, Nathan? Are you in on this deception that Riley's been involved in?
Yeah, this
What?
is
Sorry,
huge,
say again.
like ridiculous.
I said,
me
are you
again,
in
sorry.
on this deception that Riley's been involved in?
What deception?
So you watched my
This-
video.
I did watch
think
your
I
video.
outlined the deception. One, that he knew he was higher and didn't tell us, and two, that he made a second observation at a higher at a higher elevation.
Are you
He
theorised that?
lied to where he was doing it.
Are you now claiming that as proof, Jem? Because you made it very clear that you were making a theory.
Oh no. There's
talking
data.
about the
No, there's data.
when you line up the images,
said there wasn't
you see
any
they're at
data.
different spots.
I'm talking about the metadata.
I asked Jem a question. I get
actual
3
video.
answers from 3 different people that aren't Jem. It's amazing.
What was your question?
Okay, well,
So at the end of your video, you made it pretty clear that you were theorising what could have happened. Now you're claiming it like...
Actually, well, before you go any further, I made it very clear what we knew and what was theorising. So I want you to address what we knew, which is...
What did you know?
A, that Anthony knew he was higher and didn't tell us, and B, that he went and when he did his second observation, he was higher than on the first.
yeah, and C, you're okay with it. That's a big one.
But that's what we know, right? That's
My
not
speculation,
theorising
you can
motive.
dismiss as speculation, but I've
Yeah,
outlined
and
what I thought we knew. And I was
and
very clear to make it separate because I knew you guys would do this.
And the ferry wasn't the lighthouse. Really, all the data we got from that video came from Globers, except for Ranty pasted all the pictures together.
Why did you deny that it was the Girl Guides? I know they're just called guides now, but why did you say it wasn't Girl Guides?
I didn't know. I don't think, but I think that's irrelevant. I mean, all it says is they contributed to the map. I mean, we don't know what that means. I think it's unlikely that they gathered the data for the contour lines, but you could just reject that map. Use the Ordnance Survey map. They're the same. It's silly, and you know it is. And again, that's why I showed both maps.
3 or 4 hangouts ago, Ranty came on at the very beginning of the morning show. I think it was yesterday. And what he did was he went through the Ordnance Survey map, the current one, up to date, bang up to date, and compared all of the land masses on Google with the Ordnance Survey map, and they all matched.
Well, I haven't seen that.
Nathan,
I
no.
don't believe that for a moment.
Just go and check it
It's a
out.
lie because he didn't go where he was standing. Because he goes, well, you just have to take my word for it. There's not a number up here. And he circled
Which
around
debate was
his,
that on, Nathan?
I think it was either yesterday morning.
I'll make you eat that claim if it's not correct.
It was
I think
yesterday morning.
Because that sounds like bullshit to me.
Well, check it out. Like I say, I'm just repeating
The
what
thing
was
is, Nathan,
presented
if
to
you
me.
think about it, we know what the I'm sorry to cut you off. We know what the resolution of the Google Earth data is. We know how it's gathered. These, it shouldn't be the same. It shouldn't be. It's just not accurate.
I understand entirely. Just check it out. It's either 4 shows ago or 2 shows ago. It was the morning show, and literally immediately Ranty jumped on and started presenting, so it won't be difficult to find.
Yeah, I think it was yesterday. Pretty sure.
Okay.
But just check it out, yeah. But I'd agree with you with the Pontchartrain bit with that dip. When I saw that, I was like, well, it's gone down 12 feet according to this graph over 12 hours. That just seems like ludicrous. You don't get dips like that in a lake over 12 hours. But there it is on the graph. That's what it shows. And it seems to corroborate what he showed from the USGS.
Yeah, but I think we need to know precisely what that is, because it could be that, it could be that there was no data that day, or...
Yeah, exactly. Or the gauge went wrong or something like that, and then the USGS have just referenced it.
But again, it could be some extreme weather condition, or I don't know. It seems like too much, doesn't it, for one?
Well, they have bilge pumps there too in those areas that will suck up the water, and maybe there was a big rain and they sucked up too much water.
And also, if it's over this, I mean, I don't know, but if it is over the same time period that Soundly was looking at, then you'd expect to see it repeated, throughout the lake, or maybe.
How you doing, Spurs?
I don't know. Maybe not. Maybe at more than one spot. I would have thought. But
sure. How you doing, Spurs? Good to have you.
Hello. Good morning. Good morning.
Hi,
Good morning.
Spurs.
Yeah. I mean, why are you not bringing up Soundy's life?
He never lied.
Oh, I agree, Spurs. Actually, why don't we talk more about Soundly stuff?
Yeah,
Instead of talking about
he's
nonsense
obviously
around.
manipulated the positioning where he's standing.
Oh yeah.
How has he obviously done that? Are you able
Yeah.
to show that?
He has GPS coordinates,
Yeah. Should we look at
and
Soundly
he shows
stuff?
it. He videotapes himself doing it too.
It's not a bad idea.
Yeah, GPS coordinates. Imagine that, and he gives you the actual barometric pressure, so you can do the math yourself.
Joined by
Not like
Ranty. How you
that
doing,
happens.
Ranty?
Panty.
Was
Show
that
us
right?
your map, Panty.
Anything but Soundly. Anything but Soundly.
So just before Ranty gets into a wrangle-dangle with all of you, can I just establish with Alex, do you now understand that there is a 1,000-foot wall obstructing our view of that land?
No, I saw it a wall.
Stop
I'm sorry,
saying
Nathan,
that,
it's not a
Nathan. It's
wall.
ridiculous.
You were talking about viewing a lighthouse. I mean, how big's the wall between you and Ireland then?
Right.
And it was a ferry.
So if we
too.
clarify
How
that
big-
we're talking
how
about the
big's
land
wall?
at the far end of the Isle of
how
Man,
big's
do
the
you
wall
understand if I
between you
explain it
and
that way,
Ireland? Yeah, but I'm
Alex?
talking about how deceptive the way you're wording it is. You confused the guy. That's why I was angry. I was angry. You're saying, how big's the wall, Nathan, if I look down at my feet to whatever's below me?
Yeah, 1,000
I mean,
feet.
a
It's actually
huge wall.
1,200
It's not
feet,
a
Alex.
wall, Nathan.
1,200 feet wall.
Obstruction.
Yeah, a wall.
It's not a wall, is it? What is
Yeah,
a wall,
wall.
by definition?
Wall of earth. Yes.
It
yes.
astounds me that you're still hammering away at this, Nathan. When this
I am. I'm going to
evidence
continually
has just
hammering
been
away
shown
at
to-
it
shown to be
because,
so
Jen,
crappy on so
there's a
many levels.
1,200-foot wall
really
of earth
quite
curve
sad,
missing,
And you're just
and I'll
totally
keep talking
bought
about
into
it
I don't
indefinitely.
Really quite
understand.
sad.
I know you
And
don't
you
like
can't
it.
see the beach.
See how angry you
Well, let
all
me
got
clean
really
this up with
quickly,
you, Nathan.
immediately
Why
talking over
can't
me.
you-
Before I even
Angry
finished
guy
the sentence,
here.
you want to shut me down and shut me up about it.
Shut me down, yeah. I
Nathan.
want to come on here and insult you. I don't want to come and shut you down.
So do you understand now then,
confusing
Alex?
anger.
Do you understand it?
Frustration, Nathan. You're
Yeah, man.
frustrating people. We're not
Anyway,
angry.
we've got a new guest. Got a new guest. How you doing, Paul? Good to have you.
Yeah,
I
good. I've just
I
got to
do
put
get
my-
angry. I do. It makes
Yeah.
it makes me angry because I feel like I'm being insulted, like I'm being
Yeah.
taken for a fool.
I want
That's
the
what-
video
that's
data.
what
I
they
want the
do. That's what
metadata.
they do.
Is that too much to ask? Is
But
that
that's what
really
the
too much
whole
to
of
ask
flat-
for the metadata?
But this
I
is
mean,
what
you
the
guys
whole of
asked for
flat
it for
Earth
us.
is.
I mean, I'm pretty sure we get the metadata. There's a reason why Anthony doesn't want to give us the metadata. Ranty, you probably know too. Nathan, hopefully you don't know. But I think there's something in the metadata you don't want us to see.
I don't care about the metadata. Where's
Yeah,
the
I do.
beach? Where is the beach? The Earth's
That
not
too.
flat. All you're doing is showing pictures of curvature, going, oh, where's more curvature? But where's the flat Earth?
No, where's the
pictures?
curvature blocking the view, Alex? Where's the curvature
Oh, there's
blocking
no
our view?
31
beach, Nathan. Where's
It's
all the
31
lighthouses?
miles only. That's
I
like
mean,
400
Alex,
feet
why
of
is
curvature.
it-
I think Nathan's
it's
got to
the same
explain
point
why we can't
Saturday.
see all of the Isle of Man.
Alex,
Right.
that's what we want to.
Why can't we
is
see
Sandy
all
the
of
only
the
one
Isle
to
of
get
Man, Nathan?
this quality?
Why can't we see Ireland if the Earth is flat?
Because he knows what he's
far
doing
away.
I think
first.
we can see Ireland.
He knows what he's
No
doing.
Because
wall.
why?
Take a
Because
video.
why, Tony? What's the
All of
reason?
Isle of Man.
He knows what he's doing. This is his job. That's like what he
Yeah.
does.
Yeah.
He
Yeah,
knows
they're
what
never
he's
wrong.
doing. He
He's
knows
the
how to
only
use a
guy
camera.
out of all the ballers to find curvature because he knows what he's doing and the other ballers
No.
don't.
Dude, Riley's found
You obviously
curvature
haven't
many
been
times.
looking,
He's
huh?
got
You
a
just
video
sit in
where
your
he's
little
got a
room.
boat going over the curve. I mean, he's
No,
finding
we
it all
don't
the
need
time.
to see curvature.
Reds has
apparently
done
now.
it.
Well, he admitted it was
Apparently
just
now
like
we
boat
just
going
need
over the curve.
Stanley's camera and we can see curvature anywhere.
No, we can
Anyway,
use
we've
we
got
can
the-
use Riley.
P900. It
We
sucks
can
you
Paul,
use
guys.
the
Riley.
It's better than
hologram
you guys.
apologist. Got Paul, the
Not
hologram
focusing.
apologist, asking me why we can't see the beach. So maybe I'll ask Paul,
Oh,
why isn't there a
apologist, I'm a
1,300? See, Alex is
apologist.
triggered already.
Yeah.
So why haven't we got
Use the
a?
apologist, Nathan.
Why
The
isn't there a
flat Earth
13-foot
religion.
I know,
wall,
that's crazy.
1,300-foot
There's like
wall in our
1,000
way of that
Everything
land?
you
You're in a
say,
cult.
Nathan, is
Paul.
projection. Flat Earthers are the master projectors. They call everyone indoctrinated by
Not at all.
believing a load
Yeah.
of propaganda.
You're indoctrinated.
What do
You
you
believe.
call
You're
Alex,
retarded.
You
All
believe
of us
there's
are
a
in like
1,300-foot
sound-
wall
you
blocking our view of
Flat
something we
Earthers
see.
say.
Literally
You
flat
guys
Earth.
think
What
there's a
response do you
1,300-foot
expect
wall
when
in the
you
way.
see
Some of you
they
do. The
took
ones who
video
get
of
it.
fake curvature?
Alex
think we're all
doesn't really
stupid.
get
That's
it.
fake curvature. And just to
Nathan-
say that.
Lou
Funny
doesn't
thing is,
really get it
metadata.
either.
Nathan thinks I'm so dumb, yeah, and maybe I am dumber than Nathan, but I got this one a lot quicker than you. How many years have you been thinking the Earth's flat?
Yeah.
Do you know what I mean? It's not hard, Nathan. That's
So you,
Check the
so you
metadata.
do
Must
see,
kill
so you
you
do
that
accept that
someone
there's a
as dumb as me
1,300-foot
can
wall
get
in the
this,
way
and
then,
you can't get the
Alex,
simple
of that
thing about
land.
where the beach is.
You do get it then. There's a 1,300-foot wall in the way. You
No,
understand
there's
that now.
not 1,300
No, why
feet. It's
do you keep
31
repeating
miles.
it, Nate?
Where do you
Oh,
get
it's getting
1,300
bigger now,
feet
is it?
from? Yeah.
Getting
Sorry.
bigger, yeah.
2,000 feet.
Since one is 31 feet.
Yeah, of
Oh,
course.
maybe
It's
1,500.
sorry,
Yeah,
my
debate
mistake.
where
It's
you're
only
like,
the
it's a
ballers that
1,000-foot
can fudge the
wall.
figures.
It's
It's only the ballers that
It's a
can fudge the
200-foot
figures
wall.
downwards.
It's 375
It's a 500
foot wall.
No, it's 73 feet.
That's 1,200 feet. 1,200 feet, Paul. So where is that
Oh,
1,200-foot
1,200
wall?
now.
Why
Yeah,
isn't it
yeah,
blocking
yeah.
our view,
Not
Paul?
1,200.
Listen
Why
to
isn't it blocking
yourself.
our
It's going to
view?
be in 5.
Embarrassing.
It's
Anybody
just you,
gonna answer
you and
me?
a couple retards
Why
think it's
isn't it
1,200
blocking
feet.
our
Everyone else
view?
thinks it's around
Anybody?
400.
Anybody going to answer that?
So
Anybody?
why can't we see all of the Isle of Man, Nathan?
Why isn't it blocking
Why-
our view?
Why do you have to go up
We
on the
do
cliff
see the land.
to take
We
a
do
video?
see the land,
Why do you
Paul.
have to go up on the cliff
That-
to take
that
a video?
piece
I
at the
think
end,
it's
Paul?
because
We went over over this? We do see it.
Lighthouse.
It's 50 miles away, Paul.
And why
Should be
is
behind a
Nathan now
1300
claiming
foot
that
wall.
refraction is the real thing?
Any particular
Yeah.
reason why we can see it, Paul, when it should be behind a 1300
Why
foot
did
wall?
Ranty appeal to refraction yesterday to
Doesn't want to
explain
answer.
that sound is
Doesn't want to answer.
thing?
He's reverted
Yeah,
back
that's
to the...
funny.
Paul's reverted
All
to
of
the
a sudden,
moron
Ranty now
approach.
accepts that refraction's a real thing when he argued against it before.
Refraction that you use to co-opt curvature, I say, is nonsense. Refraction does exist. I've never denied that.
So in my mind, if Sally did
I'm sharing a screen. If you want to present me,
It doesn't
Yeah,
matter.
go ahead, Ranty.
Spurs,
around.
all you have
Like
to do, Spurs, all you have to do is check the metadata.
Is that correct, Jam? If he pans all the way around 360 degrees, you should see the same curvature all the way
present
around.
Ranty. I'm not going to get an answer to my missing 1,200
you're an
foot wall then.
idiot,
Nobody got an
Is that
answer? Just going to be
correct?
asked
Is
where
that
the
how I
beach
understand
is.
it?
No.
Nobody going to say why we can see the land without any 1,200 foot obstruction in the way? No, nobody?
Well,
Nobody?
Because
I don't think you've established
the footage
what
is
land
fake.
we're seeing at
Show
all.
me the
In fact,
beach
your
I've been
claim
asking.
of what land we're seeing has changed pretty much on a daily basis.
Don't mind.
Yeah,
You can
because
call it
of what it
either
is.
Ireland or
So-
the Isle of Man. I don't mind either. It's much worse for you if you call it Ireland.
Well, the thing is, Nathan, you do need to
Come on, it's
mind
gotta be one or the other.
which
It
one.
can't
Yeah, that's got to be one or the other. Either
If you're
This is not
presenting evidence,
Ireland.
geography.
you need to know for sure what it is
Ireland
you're
with several
presenting
miles of curvature missing,
Not just
or
be looking
the
at
Isle of
that
Man
piece
with
of land and
1,300
just
feet
declare
missing,
it's
which none of you
Ireland.
seem to want to
Or if
address.
it's not Ireland,
All
but
right.
it's
You all want
the
me to
Isle
shut
of
up
Man
about it. You
missing
say,
feature.
oh, we're sick of this Isle of Man stuff, but yet I
about
ask
the
where a
celestial
missing
spheres?
1,200
The two
foot
celestial
wall is.
spheres.
No one gives me an answer. They just ask me where the beach
How about
is.
the sun?
I did
and
answer,
moon
you just
rotating
talked
on
over
the
Or
flat
talk
Earth?
about how it's a holographic projection of the land behind this 1,300 foot
That's
wall.
just a silly straw man. That you're
No,
making.
that's what it has to
Celestial
be.
spheres.
There's
How
a
they work.
1,300 foot wall in the way, Jem. So
Nathan,
if we're
do you
seeing
know
it
what
and there is a
happened now?
1,300 foot wall in the way,
No, okay.
then it's a
I don't know why you
holographic
keep
projection of the
talking
The
land.
main thing is, Jem, according
Looming.
to
It's a
Sally's video,
mirage.
we're supposed to be that lighthouse.
I don't know what you're doing here.
See, now we get the funny
must have called you
sounds.
up. Nathan must have
I
called you
think
up.
they've
like, he's
invented
now-
a new area of science called
Anyway, we've got a
quantum
new
geography.
guest.
Paul,
How you doing,
quantum-
Sanders?
This is
Ireland.
Got a
10
new
miles
guest.
into
Let's turn you all down just so I can get my introduction in. How you doing, Sanders? Saunders?
It's not when you do it, which one it is.
But
How you doing,
according to Sally's
Saunders?
video, that lighthouse should be well hidden.
And
Yeah.
can I just check, Nathan? I just
No,
want to check
you can't
one
until
thing.
I've done my
Jeremy,
introduction
I'd
to the
like
new
you to push
guests.
over
So
that.
we've been joined by
Yeah,
a new
let
guest
me
called
speak.
Sanders,
Let me
who's
speak.
going to get an
Yeah, but
introduction whether you guys like it or not.
Sally's videos.
So let's turn you all right down until I can introduce the new guest. How you doing, Sanders? Hello. No, I need a verbal
Video's
hello
fake.
or I'll boot you.
Right, so this is Soundly's image, 10 miles away.
10 miles.
Where's the clarity with the rest of the pylons? Where have they disappeared to? Where's the
Wow, I love how
Where's
you
all this
pick
gone?
like a terrible.
Yeah,
I
but
just-
it's still
you know,
better
better one.
That has,
You know he's got
that has
much
This is
better
fog
one
one.
house on
stuff in
his
it.
drive. What about this
He's got a
one?
clearer one.
Yeah, because
What
he's
about this
honest.
one?
There's the curve right there. You can't see the
Yeah.
curve.
Yeah. Where's the
Jeez.
clarity?
Before
with
we
the-
move on to this, I just wanted to check.
No.
Nathan, you said
Are you
Look
serious?
at
said that Ranty's map
An
was
idiot.
bang up to date. Ordnance survey, is that right?
Yeah. You're putting a lot of weight on Ranty and Anthony's dumbass.
I know, hilarious.
No need, man. No
Because
need.
you know
He's
what
here.
I'm
You
seeing
can ask him.
is-
Ranty's here.
Okay.
Tell us- well, I'm asking you what that was your claim. I'm examining your
Yeah.
claim.
Why is this so clear and Soundly so unclear?
Because the map I'm
Exactly.
seeing
That's not
says,
clear. Are you joking? Are you
Right,
serious?
Exactly. I want to
Why
know
is the
why we
distance-
can see
Guided
the
like-
lighthouse,
this is
but
twice
according
the
to Sally's
distance.
video, we're not supposed to see any of that
Oh,
lighthouse.
wait. Ranty.
This is
Ranty,
twice
why
the
don't you
Assembly,
look at the
if
raw
Sandy
data?
don't want
went
to talk
to
about
the
the lighthouse.
Look at this.
If Sandy did Ranty's experiment, he would not see
But
the
What's wrong
lighthouse.
with that? That's
Sandy would not.
What's this?
so he takes like all pictures
What's
and
this?
some have fog in it, and you're talking about
we're
the fog.
distracted
Oh,
from
some
my point that
fog in it.
Ranty's map is actually over 120 years old and it isn't bang up to date. Is
What?
that?
What are you
Oh
about?
dear.
Oh dear.
you
me.
still see the curve.
I've still got the Ordnance Survey on here. Would you want to go to it? It's cad.ukmapcenter.com. If you have a look here.
So
you
it
can-
it obviously means that a flat earther is lying or ball earther is
Here we
lying.
go. This is the
All you
up-to-date-
got to do is check the data. All you got to do is check the data
Right, so
Spurs
this
on the
isn't
video.
Ordnance survey then, is it?
Oh, you didn't see this, did you know? All right, okay. Well, there you go. Try
But is
and
this
find it again.
Ordnance
Better luck
Survey?
next time.
Is
Right.
this
And I got
Soundly.
someone to check the data too. I know someone who knows how to do it too.
Right,
Hold on.
Soundly.
Jem wants to
Soundly.
establish if it's an
Soundly.
ordnance survey map. Hold on. So Jem wants to establish if it's an ordnance survey or not.
What's the rest of the
If
pylons? Why
Sandy
the-
was to go to St. B's, he would get different results to Ranty, right? According to-
Yeah, 'cause
Ranty,
he knows
sorry
how to
to
use- he knows how
interrupt.
to use it.
Sorry to interrupt, Spurs.
Where is the
camera.
definition? Where's the definition of the pylons gone after 10 miles? Why aren't we seeing this?
There's
Why have they
fog, dude. Are you
disappeared?
serious? Are you seriously
So it's
bringing this?
fog.
See,
So
this
we're looking at
is your
fog.
argument
Agreeing
right
that
here.
we're looking at fog. Do you know what causes fog?
You pick
Do you know what
fog.
causes
Good
fog?
job.
Do you know how fog is created? It's when you have cold air under warm air. Do you know where this? Do you know where this Lake Pontchartrain is?
Pontchartrain.
Below sea
So
level.
it's refraction then. We
No,
get
it isn't
So-
below sea level. You
What
didn't
saying?
establish
we
that
have.
at all.
You just said
You
it's
haven't
fog.
established that at all, Ranty. That's
You've just
a
said
lie.
it's fog. Oh, have I not? River
you
gauges.
haven't.
Okay, here we go. So here we have the river gauges for Lake
Oh, the ones you didn't
Pontchartrain.
know about, Ranty?
Right.
The ones you didn't know about?
Well, why are you showing us a river
I only had to
gauge?
tell you.
Minus 0.11, minus 0.07, below, minus 0.19, below,
Why
do the
are
average,
you
Ranty.
showing us
Do
the
the
river
average.
gauge?
below sea level.
Do the average.
Below, it doesn't
What's
matter.
the average,
on,
Ranty?
on the 22nd of the 3rd,
Okay.
on
There
the
you go.
22nd
There you go.
of the
Doesn't
3rd,
matter.
2017, the value was
Ranty, why don't you give us the raw?
below sea
Why do you
level.
keep talking
You
over people,
realise
Tony?
we know that-
Tony,
No, no,
why
no,
do you
no,
keep
you're not
talking
gonna get
over
away
people
with
when
it.
it's trying to make a
No,
You
point?
just admitted that there's fog on the horizon. And I've
Ranty,
just
what
showed
is
you what
that?
happens and how fog is created. Fog is created when you have an area of cold air beneath the warm air. This
Ranty,
this water gauge falls below the sea level. The cold air filters and sits on this lake. The warm air sits above it. It creates the fog, and it gives the impression of the superior mirage, which is indicated here right now.
Except for he doesn't
in
take
this
the video,
video.
like okay.
Except Superior Mirage
In
is
this
lifting
here.
up, Randy,
What
not
is-
bend
that's
them down.
ridiculous.
No.
You are such a liar.
No.
Superior Mirage
Not
is
having it.
lifting
No,
up. They
you
don't
didn't.
bend
No,
them down.
no. You just told me it's fog. You just told me.
Superior Mirages lift things up, Randy. They don't bend them down.
You just told me this is fog.
I did.
I didn't
Right.
say anything, but I know
I did.
that Superior Mirages elevate things
Okay,
in the
so where's the
distance. They
definition
do
of the
not make
pylon?
them go down.
So where's the definition in the pylons gone? Why did they disappear? Why, when we look at this
They're
image
still
here,
curving, though, aren't they,
Right.
Randy? They're
Why-
still
why
curving
when we look
down.
at
It's
this-
clear that you can see
Yeah, they're still curving down.
Randy.
why is there no distortion here? Why is
Really,
this clear? Why is
because
this
you
clear?
photoshopped
There
it. Dude.
probably is,
Why
You
is
want
Randy.
to lie?
clear?
Like pretty much, it's already been known that you photoshopped this.
It's
If
been
you want
done
to
on a
be
video.
going with this shit,
I'd say
How
Sam
can you
has
do it?
photoshopped
It's been
everything he's
taken
done.
from a video. Come on. So this is very
dude,
clear. This is very clear.
all you got to do is give us the metadata.
Well,
Well, I think
it was
you need
sound
to
like
have a
one,
look at
It was so
very
clear.
clear.
This is unclear. Look at the look. You
If
can't.
it's so clear, why can't you identify
This
anything
is
properly?
If I crop this out now and said to you, "What is this here?" You wouldn't be able to tell me, and that's just 10 miles away. And this is pylons.
Yeah, but he wouldn't use this as his main evidence.
It's on his
because it was
Google
caught in
Drive.
the morning.
This is his Google
It was in
Drive.
the morning, dude.
Look, Google Drive,
Yeah, I know, 'cause it's
drive.google.com.
honest.
This is
You
what
give
he
all
has
the
uploaded.
You guys
Prove
leave out
thousands
the
of
curvature.
observations. Some that are a
He
lot that are
has this
clearer
as
than
proof as
this.
curvature.
So what? This is meaningless. He has.
No, it's not meaningless.
Yeah.
It is because he's
This
got
is
dozens
what
of
goes on
observations,
this
and
lake.
you just picked one that's
The
particularly
gauge.
foggy and
The
gone,
gauge.
oh, fog's
Yeah,
the
why don't you
cause
pick the
of
good
it
ones?
all.
The
Someone
gauge
get
of
the
this
good
lake.
one. Someone
Do you
get
want
the
to
good
see-
one.
Let me ask you. Let
No,
me
no.
ask you.
Do you want to
Ranty,
see what the minimum and the maximums are
Ranty,
for
let me
this
ask you.
lake? Because here we
Ranty,
go. Look,
Ranty,
Lake Pontchartrain
let me
at Lakefront
ask you a
Airport.
question,
We have a gauge here of minus 4 feet, minus 5 feet, minus 7.3. This
Why
is
are
the
we
minimum
arguing
that it
about
went
the
to.
What is
level?
it
I
you're
know,
looking
I
at
know.
for a
He
start?
thinks
We
he
don't
knows
even know
something
what you're
good,
looking at. But I
The
want to
level of
ask
the
you.
lake.
No. So
Totally.
what happens
wanna ask
when
you-
cold air? What happens when cold air is below warmer air?
Well, how have you determined that? What
It's
my
the
question
south
is?
too,
I'm
dude.
asking you-
Like the cold air
I'm asking
leaves
you
right
a
away.
question.
Simple rule of physics, I would have
my
said.
It
Actually,
really
Jen.
is just a question.
It's just
You
basic
guys
physics.
should know all this. I don't
Basic
have to
physics.
The cold air,
educate and spoon feed it to
leaves.
you. I don't have to spoon
Don't
feed this to
pretend that
you.
don't
You act all clever, and I'm asking
Warm
you
air
a
rises.
serious, a simple question. What happens when
We
cold air
don't know
sits
what you're
underneath
looking at.
warm
We haven't
air?
had time to examine the claims that you made.
No. Answer the question.
Yes.
You're
Stop
clever.
talking
You
and
can do
answer
this.
my
I don't have to
question.
educate you.
What is sea level?
I don't have to educate you.
Ranty, what?
You answer the question. What happens when cold air sits beneath warm air?
Okay, you've made that point.
What happens when you make the
It's not
observation
a
when
point,
it's
it's a question,
not
Jem.
Curves down.
cold?
It's
What was
a
it that Jem
really
said to me
simple
earlier? Are
question.
you obfuscating, Jem?
We get superior
Are you
mirage.
deliberately
Trying to
being
answer the
deceptive
question
by
for
not
10
answering,
minutes,
Jem?
and I
Are you
can't
just
even get the question
obfuscating?
out. So I'm not obfuscating.
Because I'm so frustrated. with
Don't
you.
lie.
You were so
Stop lying,
different.
Nathan.
He's making it sound
You
like
even just said,
Louisiana.
you even
A
just
lie,
said
it was a
I
question.
used
I wanna know
a 100-year-old
Did you hear the
map yesterday.
phrasing, Jem? It was
You
a
just
question.
said that I used a 100-year-old
Are
map on my
you
ordnance survey.
obfuscating?
And
The one I'm
I still
looking
have
at
it.
is
I still have it up here.
survey map.
This is a CAD map.
Right, so it's not an
Listen.
ordnance survey.
Oh, is it?
I
Oh,
made
you
that
read
claim.
this?
I was
Have you read
wrong.
this? Have you
I was
read
wrong,
this?
Jem.
Ordnance Survey master map topography layer is the most consistent,
I was wrong.
comprehensive, accurate digital representation of the geography of Great Britain available from a single source. It is also used by governments, etc., and is at the heart of central and local government policies and processes. You can buy the images.
Could you please put the link to that in the side chat, Randy?
Yeah,
Right.
can you put your raw video of this in the side
The
chat?
raw video is up from yesterday. It's on.
No, I mean the
Nathan's
raw, like
You put
the
the
one
link
you
in,
first
please.
took.
So,
we can see
to actually, so for you to come on just before and say that I was using a 100-year-old map is ridiculous because I did this
I asked Nathan
yesterday morning.
Well,
So
I looked at
just so
that's the map I'm looking at. Okay,
Yeah,
so
exactly.
I got the wrong map. Okay,
They
but I
held the-
went
they
on
held the map
Nathan's
back.
direction and I looked back and saw a map and I went with that map. Okay?
Yeah, didn't you? See ya.
How you doing, P? Good to see
Well,
you.
Nathan told him to.
I got it wrong, Jem. I said
Can
it
I
was an
just say,
AS
you've
map and I was
lost a lot
wrong.
of weight. You're looking very good.
I was wrong.
Do you
I just
have a
made a
reference
mistake.
to it,
I thought it
Nathan?
was Ordnance Survey. I was incorrect. My apologies. Anyway, P, how you doing?
All right, cool.
I lost mass.
Yeah, can we
And
just
the
congratulate
Weight isn't real.
You look a lot healthier,
It's like
man.
hardly ever cold in
Good work,
Louisiana.
man. Good for you, bro.
Lost density.
Well, you made out of your pockets, like you lost some poker.
Comes from, because a lot of them are going to use the same data that Google Earth is using. That one,
it
to
doesn't
be
matter.
fair, that one doesn't look like it is because it does have, it looks like it's got fairly accurate contour lines.
Explain the celestial spheres. Do that without refraction.
Here, go on, Nathan. Have fun
Explain
with
the
that.
celestial spheres.
Tell us about the third celestial pole.
Do that without saying it's a hologram or Arwen's magical tripping lights.
I don't think Nathan knows what hologram is.
See, I think that you guys pounce on this curve thing because it's the only thing you guys can sort of make kind of sound cool. You guys don't really touch anything else. Well, you guys try to touch other stuff.
Been joined by Make 4. How you doing, Make 4? Good to have you. How you doing?
Sometimes I touch myself.
Me too.
The Earth is flat.
Would you guys snipe all the flat earthers?
What?
No, Ranty left. Like you said, see you, and then left.
Didn't give you the link either.
Paul, don't steal my idea.
Right.
That's I have a boat.
We didn't get to see the actual thing, did we?
Yeah, and I still want the raw footage, which shouldn't be too difficult to get, because every experiment tour usually gives it out right away without having to ask.
Yeah.
But I think there's something on this metadata because if you look down where the water hits the land, there's something weird going on there. And a couple people that do Photoshop and looked at it too, and they say, it looks odd. It kind of explains why it's been gone for 5 months, this evidence. He took it and just forgot.
If this is such a great find, why aren't other flat earthers talking about it?
Yeah, exactly. Because they know it's bull. Because they know it's, they probably know it's Photoshop too. Because all Ranty does is Photoshop stuff. And I wish that was a lie, but it's not. We have evidence of it. And then he missed the coordinates on the last video. I don't know if it's willful or if it's just, if y'all you guys are in on it.
He's just copying his mentor deep inside the rabbit hole.
There you go.
All right, to make this more constructive, if Anthony was to return and to repeat this observation, as would be required really to establish it, and in fact repeat it several times. But if he was to return, what could he do to make it more irrefutable?
His word is so shot now. Oh shit! Sorry.
I mean, I think what he could do is he could zoom in on bits of the land, and actually focus his camera so that we could then identify, specific buildings that we could, get elevations of. And
sorry, Jem. How you doing, Mike?
Sorry, no.
Morning.
Oh, sorry. Go ahead.
Sorry, that's it. We're done. And we've also been joined by the Rumpus. How you doing, Rumpus?
Hey, Rumpus.
Yeah, I can provide identify objects in that picture quite easily.
I know. I need to hear what you've got to say on it, Rumpus.
Yeah, I've got
that red line. Did you knock it down?
I've got a half-baked presentation on refraction here that I've been just got back from sort of Christmassy things. I'm about 3/4 of the way doing it, but I could do a quick thing on refraction, just show what this idiotic comments like is a hologram. Just kick those into touch straight away. I could do that. Okay, I'll say this is only half-baked this presentation, but it might do some use. I was going to finish off getting the because the thing I haven't considered properly is the thing that
Did you tackle the red line, Rumpus?
Yes, that's another thing I need to.
Because we all think the red line's way too high. Like
it's idiotic in principle. So
what are you trying to do here, Rumpus? What are you going to prove here?
Well, this was what the presentation would be about. What refraction does. I haven't yet tackled the height thing that Jem Pan has been looking at. I haven't been, but it's clearly more. I think it's at least 75 feet. I mean, I think I said 60 when I was my first efforts, and I think now adding in the extra heights and bits and contours, it looks at least 75 now. I think.
Just before you start, Rumpus, if I can just say to the rest of the panel, sorry, Spurs, bear with me. I'm just going to say this to the whole panel. It's clear Rumpus has done quite a lot of work on this, and I want him to be able to present it without being interrupted. If that means it takes 10 minutes, so be it. But I don't want anybody to interrupt him while he presents this.
Thank you very much, Nathan. Yeah, so this is the little title here. So those are the list. I've actually put in more than that, but I've got some bits missing. But that's the idea of this presentation. Right. So I was just going to go through. So yes, if you look at that, I was going to go through what's refraction, what are the effects of atmospheric refraction, taxonomy of terms, describing refraction, the examples of non-stand refraction, the Isle of Man map, and the view of plane Bs, and the scale model I've created of the refraction and the view lines. And I don't think I've finished my bits. Some bits now I haven't finished them, but I haven't finished bits comparing what the Metabunk Earth calculator says. Oh yes, and I was then going to add this red line thing that someone's just mentioned, invalidating that, how that can't work. The one that Nathan's been showing, which I haven't got around to looking at that properly. Right, so let's have a quick look at what refraction is. And that's just simple. And we all know this. I'm just going to repeat it just to make sure we all agree, because I mean people like Arwen don't agree with this or something, so let's just make sure we all agree. It's just simply the bending of light when light goes between mediums. So here's the example we're all familiar with, and it's usually between different densities. That's what caused, because it's actually caused by the change in the velocity of light. That's what caused the bending. And so when you're looking at a pencil in some water, it looks bent. The base of the pencil in the water, this is going from a dense medium to a less dense medium. So you've got water going to air. Light speed in water is, I think it's 30% of light speed in air, something like that. I can't remember now because I haven't prepared this properly.
Yeah, that's about right.
Right, thanks. So what you've done here lifts up the base of the pencil when you're staring into it, looking through the water. It's lifted it up. That's basic. You can check this. Aristotle and the various other Greek philosophers did it, and we can all do it ourselves. So, and of course, right. So that's the basic sort of phenomenon that we all can experience very easily. And of course, with science, you're not doing science unless you're putting numbers to things. And so here's the more. I mean, this is Snell's law. I know Nathan's familiar with this, which is here again. We've got a dense medium here, and as it comes out, it bends, and it bends in proportion again. What's called the refractive index just represents the velocity ratio. So here you can represent several ways. The bending of the light angle is the sine of this is the angle of refraction relative to a orthogonal line relative to the junction of the medium. And so you get this. So θ2 over θ1, sorry, sine theta over sine θ2 gives you the change in the velocity. I mean, I could do a wave construction, but I think we know, hopefully if we went to school back to about 14 or 15, we would know Snell's law and how Huygens, you generate a little list of wave fronts using Huygens' principle, and you can see that the velocity change. So because it's you can think of it here, the velocity is increased, and because it's going at an angle, it actually increases more in the angle that it's going at. So it goes more to the right. If it was going vertically, there would be no change. Similarly, if the angle was going along the medium, the junction, there would be no change. But if it was going vertically, there'd also be no change. So there's I was going to draw a graph actually of how where the change is biggest. And then of course, if you go too far, when the when you try and reconstruct the wavefronts, because the sine theta over sun, you can get a value greater than 1. And when that happens, you get a critical angle that actually then reflects. This only happens when going from dense to less dense mediums. You get the total internal reflection. So you do have a critical angle. That's dependent if this is a very dense medium, that critical angle will be smaller. But yes. So anyway, you get this deflection, all caused by the change in the velocity of the light, and that's usually related to the density of the, as I mentioned down here, the denser the medium, the slower the light. Right. So let's consider here a sphere with a one layer of light around it. So here's a sphere, and this is glass, or this is a homogeneous glass. So that means it's uniform, the density is uniform, and that means it's got a constant refractive index. So the speed of light throughout all of it is going to be the same. And let's imagine a light source here at the surface of the sphere, and it goes along, and then parallel, this is horizontal to the point on the sphere, and then it hits the end of the sphere and it goes into air. So this is air around here, and of course it's going to bend by a certain amount. I've chosen 23 degrees to demonstrate this. So it's going to bend the same way, and that's just following, because if you draw the, you can, I haven't actually drawn, yes, I haven't drawn on this, but there's the, whoops, that is the junction, the medium, this junction here, that dotted line is that junction there. Now imagine instead of just having one layer, you had 5 layers. Each time, so this is, so they're less, so the change in refraction, we've got the same refraction in the bottom layer of glass, so they're all homogeneous, but now we've got 5 layers of different refractive index. So the one at the top is less refractive, so we've got 5 layers, and let's say they're 1/5 therefore as refractive as the bottom. So the bottom one has the difference between the two, still the same between the top and the bottom of the sphere, but you've got intermediate layers of glass, and then you're going to get this effect. So you'll see that's just simply doing that more times, and each one is less than that angle. So this is the total. So you're still going to have that change of angle of 23 degrees, although I haven't fixed that yet. So you're going to have a smaller change, but more of them, and so you're going to get this effect. And then, of course, you can imagine if I had an infinitely thin layers of glass, changing refractive index gradually from the end one here. Actually, I should have put sorry, that last one's wrong. That should be a disjointed. It'd be smooth here, but the junction between the end of the glass and the air is still going to be a disjointed angle. So that will be smooth here to here. So we can then see what the curve of the light will be with a very, very thin layers of lots and lots of thin layers of glass. And of course, this is exactly what happens in an atmosphere, because an atmosphere is just the same, because although it's the same medium, it's not homogeneous. The density of air changes with height, and that means it's changing its refractive index. So this, in fact, you can think of layers of glass. And of course, it doesn't happen with solids because they're not compressible. You know, they don't change their density. That this glass here I had just simply is fixed. But of course, with air, you've got the same. So those are different pieces of glass in this case. I had different layers of glass, each with a different refractive index for this case. But with air, because it compresses and changes density, you get the very same effect as though you had lots of layers of glass at different refractive index. And that's just caused by what's called hydrostatic compression. That's because gravity is obviously pulling in on the air. And just like, you know, the bottom of a swimming pool, or at the bottom of a, you know, if you go to the top of Mount Everest, there's much less pressure, and you can draw a graph of the atmosphere here. So if we're at ground level down here, what we call it density of 1, the unit of 1. So in other words, it's the density over the density at ground level. And you can see this blue line is the temperature change, and this is on the left is the height. So we got a plot of density, pressure, and so this is pressure, density, pressure, and temperature against height. We're going up 10,000 meters on the left, and you can see what they do with regard to the surface of the Earth. And you can see the pressure one is the green one, this one here. Sorry, the density one I'm after. The red one. So this red one is the density. So that's going to reflect, and you can see it's changing all the time, and it's also changing exponentially. But the point is it's changing gradually as you go up in height. So that means you've got this situation here. It's changing in density as it goes up, which means you're going to get this effect. Now, what does that mean? Well, it means I was going to show you what non-standard atmospheres were here, and and how you get light to travel in straight lines. And the point, yes, and the upshot of this, of course, is that light going along horizontally does not travel in a straight line. Now, if you change the equation that Paul showed people a week or so ago from the Wikipedia page, you can actually change, if you get the right gradient of refractive indexes, you can actually get this light to go in a straight line. Or you can get it to actually such the radius of the curvature of the line actually matches the radius of the Earth. In other words, it would go, in theory, if this was a sphere, you could imagine Earth or a sphere, if you got the refractive indexes organized correctly, you could actually make the light just go around in a circle all the way around and back again and meet itself, if you've got the gradient of the refractive indexes right. And similarly, if you change it another way, you could make it such that it goes in a straight line. But those equations, I haven't done those yet. So you can, most of the time, light does not travel in straight lines if it's going anything like horizontal. Now, I think I was talking, yes, I'll do that in a minute, because it's the angle. So it's very important also the angle. If you're going straight up, for instance here, as I mentioned in the case of the initial water tank experiment, if the light was going upwards, so from someone up here, there wouldn't be any refraction because the sine theta of the boundary, that boundary I was talking about before here, you have to be going with an angle to the boundary. If you have no angle to the boundary, you'll just carry on going straight. So there's no refraction for someone if you're looking at an object here. And I'll go into that a bit more later. So if there's an object here you're looking at, but if you're looking at an object over here, or you are, so I'm imagining here, you're going to get a very vast effect. And I'll go into that in a bigger, much bigger effect. So let's go down where I was here. So what's this effect for an observer? So here we have an observer up here. With quite high. Obviously, this is this could be, but it's not to scale. This one, this is not to scale. And so there's the horizon they would have if there was no refraction, no atmosphere. So let's say you could think it was a spaceman, no atmosphere. That's the furthest they could see. Now, if you include an atmosphere, then we add in this curvature. Then, of course, what used to be, so G is the horizon as they see it normally, without any refraction or any medium to interfere with anything. But with that curved thing I showed you, suddenly they can see something at H instead of just G, because this curve, because of course they don't perceive any refraction, they don't see any distortion as from their point of view. So if the line that's coming into them is this line from J to O, see this line from H comes in, it swoops in, but by the time it gets to O, it actually from O's point of view, it came from J. So this object at H appears to be at J, in other words, well above the horizon. There's none of this business about Nathan mentioned about being two sorts of sources of images that have to match up and join together perfectly in some incredibly coincidental way. No, everything's a gradual, all the light from all things gradually. And as far as the observer is concerned, it's no different from seeing H. It just always being good. Though there is an effect you will spot, which I'll show in a minute, that does give away there's something going on. And unfortunately, my machine's decided to start saving that right good. So what does that mean in practice then? So it means, for instance, that when you're looking at the sun and sunrise, when you're looking close to the horizontal and you're getting this bending, the sun actually, when you give the sunrise and sunset figures they give in various tables, they have to allow for the fact that you're going to get the bending of the sun. The sun is actually below the horizon normally when you see it on the horizon. And similarly, when it sets and rises, so it's not actually where you see it. So you're seeing the real thing. So there's no question about the light getting to you is the real light. But all that's happened is it's just been bent by this process. And it only happens close to the horizontal, which I'll show you here. This is the local coordinate. I don't think I need to go into that just yet. And this is when Anthony mentioned once, oh, look, why do astronomers the issue, well, I can't remember what the point he's making, but it was wrong anyway as usual. And this demonstrates the refraction that occurs, and this is the degree above the horizon. So your personal horizon would be to here, to the G point G as you're an observer. So looking to the horizon, this is the refractions you tend to get. And astronomers, for instance, do not look below 20 degrees because they know this is going to distort things. And sailors, I mean, known this for centuries, they do not use observations of stars below 20 degrees. And that's why, for instance, when they were exploring towards below Africa and they couldn't see the pole star, they used to get really worried. They did that. There was a point where they just simply stopped navigating because they couldn't see the pole star, and they knew that because it was very low in the sky, which is of course something else that can't happen on a flat Earth, that they were in trouble because they knew about this effect, that when you go to low angles of elevation to make observation of stars, so sailors refused. So here we've got a 5 degree thing at 10 degrees. So sailors would work from this point here, from the 10 degree onwards. They're prepared to accept that as not being too off. And at 20 degrees, astronomers are required to be at least 20 degrees before they're prepared to make any observations. So you can see here at 0 degrees, we've got it going up to 35 degrees of refraction. And obviously, once you get up to about 45 degrees here, and when you get to 90, it'll be next to nothing. But at 40 degrees, you're still getting some refraction, but it's huge. This is in arc minutes here. So the point is, you get almost all the refractions happening very close. That's not surprising, of course, because that's where you're going to get most of the inversion layers and standard atmosphere that I mentioned up here. This standard atmosphere that I had here, this is dealing tens of thousands of meters. So it doesn't really worry about what's going on down at a couple of meters. Or a couple of hundred meters. This is the big affair. So let's go back. Right. So and of course Mick West did a video on this to demonstrate what goes on when a star goes towards the horizon. So here, I can't remember what angle this is here, but he took a measurement of the velocity because of the spinning. So the whole sky is rotating around us, and you get a constant speed. For most of the period of the movement of the spinning of the Earth, most during the day, the stars will move at a constant speed. The angular speed across the sky will be constant. But as they get to the horizon, they start to slow down. And so what Mick West did in a fantastic video here was he plotted the stars here, and then he extrapolated if they carried on moving at the speed they had, what they would. And the blue blobs here, if you can see that, are the extrapolated position if it carried on a constant speed. So this star was here. Now it's starting to separate. So the blue blobs are what should happen if it carried on at a constant speed. And the red blob is actually what the star actually did. And as you can see, as it gets to the horizon, it slows down tremendously with respect to things because of refraction, because you can see behind the curve, which you wouldn't be able to do if it was a vacuum. So obviously this wouldn't occur for the space station or anything that's above the atmosphere, but below the atmosphere, when you're looking near the horizontal, you get these refraction effects in accordance with this diagram here. So down here, you get this huge level of refraction, but not when you're looking up. So when people say refraction, yes, and this is another thing caused Anthony particular problems. He kept on saying, well, it's standard refraction. And then what non-standard refraction? What is standard refraction? It just means a value they've picked to say, well, we've got to put in a figure so that surveyors can do something. So we pick on a standard refraction, and even that's not standard. There's no standard actually for standard refraction. Some put in a value of 7/6, some put in a value of 1.2. And in fact, Metabunk thing, he couldn't decide which one to put in. He just put 7/6 in the end. So you've got the standard refraction and everything else. Now you've got to pick on a particular value. Now, all the refraction in here, you could say that's all non-standard. Might be one in this sequence here is standard refraction. All the others are not. So all those other positions, most of that is non-standard refraction you're looking at for the position of that star. And I've got some examples here. So, and then also, of course, Andy talks about negligible. Well, he's talking about negligible with regard to that paper, which is talking about inverted images, magnificently amazing images, and they regard the normal refraction that we're worrying about that's causing a difference of a few hundred feet as completely trivial, negligible, they call it, because they're not interested in sorting out flat Earth. They're interested in the gross effects that they see in all the magnificent inverted images. And so they're worried about angles of refraction of 10 degrees or inverted. Here we're worrying about the tiniest thing, and I'll show you in a minute a scale model I've got of the differences we're talking are significant to us, just like to Bill Gates, £1 million is next to nothing, insignificant, negligible. But if you're haven't got a house or something, £1 million is obviously a fortune. So let's have a quick look at some examples. So here, what comes under this is the other thing that Andy didn't understand, is that non-standard refraction, the amazing refraction, is a subset of non-standard refraction. He thinks there's standard refraction and then amazing refraction. He thinks there's only this one here and standard refraction. That's it. Well, no, amazing refraction is a subset of non-standard refraction. But so let's look at some other examples. So I've got here. This is an example of a view of Chicago demonstrating looming, which I'll describe in a minute. Which is that curving. Actually, all that is being able to see over the horizon. All that is looming. It's just that curving I showed you with that star and with the
Can you make
glass
it a bit bigger, please? Can you make that image a bit bigger, please?
I will. Yeah. Okay. So this is an image of Chicago. This is a bit of towering going on here because it's stretched. You can see a bit more, not obviously this demonstrates the spherical Earth because the base of this, I've got another image here that shows the base of this building, like the one that Cara and other people show. The base of the building is actually here, which obviously you can't have on a flat Earth. It's impossible. But it's actually stretched slightly by refraction, and you can actually see a bit more of it due to refraction as well. So that's a sort of standardy refraction. And I was going to fill in some more examples here. Okay, I've got some. So let's have some look at some amazing refraction down. So if we just simply go down my tree, the taxonomy of refraction. So we've got slightly non-standard refraction, then we've got other more significant types of refraction. So let's go and look at some of those. And I was going to, so this is the one you'll have seen. That's an amazing, I think that's an amazing refraction. I don't think, I can't remember if it classifies as amazing. There's another one. And so that I call that amazing. So there's also all the Fata Morgana stuff and there's things in here. I was going to print some more examples. So here's some more significant refraction, but let's not call it amazing. Here, for instance, is the moon setting. Oops, didn't need to do that. Here's the moon setting. If I can just expand this. Right, so there's the moon, just a slight crescent, and over here on the right-hand side, a picture's taken at slightly different times. So here's the horizon. So this is obviously a tiny angular off the horizon, and this chap has caught it just as it's starting to enter this. Well, there's obviously some sort of inversion layer here, so this is quite amazing in that regard. It's not standard at all.
Sorry, Rumpus, to interrupt. Can you make the right hand? Sorry, Rumpus. Sorry, can you just make the right-hand side images bigger?
Yeah, okay, I'll do that. Yeah, sorry. No, I haven't.
That's brilliant. Thank you.
So you can see here that the moon is breaking up as it hits that refraction boundary, breaks up into different bits. And you can argue this is very significant refraction, and then it sort of finally changes its shape completely and then goes into a blur. That's not I should improve. That's not one of the best examples, actually. Then there's the next one. This is a very significant one. This is a fantastic picture. This is taken by a flat earther in a video. And it's a view of Toronto from Lake Ontario. Now, what I've done here, let me just, you may think it's a bit confusing because I've overlaid a couple of things. Let me just remove the, I've got this in layers. I just need to remove this just to give you the, what do I need to remove? Is it that one? No, it's not the one I want. Is it that one? Bugger. Oh, friggin' hell. What? Let me just.
Not to be rude, Rumpus, but you've had a solid 20 minutes now.
Okay, I'm nearly there. I've nearly come to the punchline. Yes, sorry, I will move it in a minute. So let me. Right. Well, okay. Fucking hell! What I've got here? I can't hide the damn thing I wanted to hide. What you've got here is the Toronto Tower. And I've matched up a Google Earth thing against the picture. And what you can see has happened. We've actually got non-standard and standard effect, just a bit like the moon picture, in the same picture. And what's happened is that all the buildings, this actually is perfectly to scale up to this point here with the base of the CN Tower, is perfectly to scale, not refracted significantly at all. But from everywhere down here, it's compressed enormously. This is where the base, for instance, this glossy building here is actually this one. And it should be below the horizon, but it's not. And in fact, what happens is it's been a huge amount of refraction from this point onwards, non-standard refraction, that's pulled all these buildings up. Even though this part of the building is in the right place, the Toronto Tower, everything below it is being compressed. So we've got quite a large amount of non-standard refraction here, possibly verging on extreme. It's not quite inverted. But up here, it's not. So you can see how sensitive it is to the angle. But you can see here we've got a great variety of refraction in the same picture. And I'm near. Okay, I'll rush.
So sorry, just to clarify, Rumpus. So what you've done in this image is you've got in the foreground.
I've superposed an image from Google Earth to show you. In other words, I made sure the scale. If I could just find the layer that I put this on, which I can't.
So the background, what's on the horizon
is a picture from a video. This
the actual photo.
Video, and I've overlaid onto Google Earth the correct scale, and it matches exactly this tower, which I will be able to show if I could.
So if I can just clarify with you, Rumpus, though, bear with me. So the stuff in this background, you can't see my mouse, but I'm showing it for the audience. For instance, this dome-shaped thing is this square box. So
yes, I know that's a bit okay. If you don't want to, if you're worried about the square box versus the white thing, let's go over to another building then that makes it a little bit clearer.
No. This is perfect. This is perfect. So what you're saying is this box demonstrates that it's having non-standard refraction because it's
correct.
Right. Okay. Thank you.
So in other words, this building here should be right down here, but it isn't, and the cause of that is because it's a sunny day, very clear, lots of large temperature gradients, and that means we can see quite a long way around the curve, but only up to this, about up to here. The extreme refraction is only happening to about this height, and above here it's perfectly unaffected, because if I could show you the bit behind this matches exactly the picture behind it. So this is a part of the video here. Now I've put it in for Google Earth, and it matches exactly perfectly. There's almost no difference between Google Earth and the picture. But immediately you get down here, you can suddenly see that this building here matches that one, and this building here matches that one, and this building. They're much too high. But it's all happened within the same picture.
So the stuff with clear line of sight is undistorted, and the stuff that's suffering the effects of non-standard refraction is distorted, basically, is what you're saying.
Yes, it's compressed, and two things have happened to it here. We've got two effects here. One, looming in the sense it's much higher than it should be, but it's also compressed, which is another thing. So that's called the opposite of towering. So there are two, because it's quite severe, the refraction here. We're getting two effects. One is it's lifting everything up, and the second thing is then compressing it as well. So you can get, depending on the temperature gradients, you can get both effects. So whichever you happen to be interested. But it's just interesting that because of the compression and the looming, you get them all in the same picture, which is a marvelous example.
A quite severe example of non-standard refraction. You say?
Sorry, I missed the part.
A quite severe example of non-standard refraction.
Yes.
Okay.
Though possibly for the people who are doing that paper that Anthony's obsessed with, who call about negligible, they might regard this as not terribly significant, because they're interested in things that go upside down and flip around and do God knows what. So they might not. That's why I didn't put this in amazing. I put this in non-amazing, significant, whereas the amazing ones, is this sort of stuff. So you could call that's just another, even more amazing. So this is more what the people who are doing that paper in which they call negligible refraction. Right. Anyway, so let me just try and finish without taking up everybody's time. So I've still actually got probably I'll have to really dash through this. So we know the situation, St. Bees, and from my analysis of the photograph, I'm absolutely sure that the thing we see on the right hand side, not the buoy thing that we discovered that was brought up recently, and the left hand side is to the mountains to here of Douglas, and we know that from the calculations that I did on the picture, and I can identify all the blobs in the picture taken. I can get a heading on them, and of course when I think I saw the thing Anthony did with that Steely chappie, whatever his name, Dan Steely or something, Steely, he said he put the image, but of course he didn't check the image. He might have been using an incorrect image. That's why he has not validated that the bitmap that he was using. And of course, when Anthony said, oh, but all the globers are using maths, and here I'm using a 3D program, that's using the same maths. And in fact, I did a more rigorous job in doing it, because I checked all the points on the bitmap that he was using against images in the Isle of Man. He just shoved the bitmap in a particular random position. He didn't check it. He just aligned it with one point, though I think he may have checked the buoy as well, and I did it meticulously of making sure that bitmap was in the right place and the headings on it. All he did is he shoved it into his 3D program. He didn't check that the composition was correct, which is what I've done, and I've made sure it's all right. So he doesn't know that composition. We know on two occasions the ones being given have been wrong, both of them. So he didn't know what was wrong. He just simply took the image as it was, and he shoved it in a spot in his 3D model, and then said, oh, look, there we are, lines of that. So he thinks, well, if in my 3D program, which is just using the maths like I'm doing, but it's doing exactly the same sort of maths, his 3D program that I'm doing in here. So there's that's the view with my image. And so I believe that this is the image on the left-hand side of the thing you can see. So you can't get to Douglas. This is the lighthouse. That is this blob that... that's the house, I think, there that Anthony said, oh, look, this might be on the beach. It turns out it's in Bella. Oh, sorry, that one, I think, in Bella. And I've identified another one here that was just to the left of the, which I don't really have time. I'm using up everybody's time here. Well, if I can but with my picture, this picture down here, I can identify anything on here. Any white blob you can find, I can get a heading to it. And this is how I identified where a particular house was, and I would then use them to Google Earth to go and check that it was that house.
Can you identify something for me on
anything, and they're using just maths, which is exactly the same thing.
Can you identify something from?
I can go and find out where any one of these white blobs are, get a heading to them, and then work out.
Can you identify something for me, please, Rumpus?
Okay.
Can
You want me to do it
on the Isle of Man picture, if you would?
Oh God, it takes me. But I have to do all the line drawing, and I have to, I have to work out what the angle is. I mean, it takes me about 5 minutes, if not more.
Just try. If you could just bring up the image just for 1 second.
Okay. So it's this image here.
There we go. If you could just anywhere on there identify any effects of this refraction that are visible.
Well, it's all subject to refraction.
Yes, if you could just identify some of those visually obvious effects that we can see of this extreme... Hold on, can I just get to the end of my question? So what we have in this example, according to you guys, is extreme non-standard refraction?
No, it's not extreme. No, it's very, very slight.
Oh, it's slight non-standard refraction?
Yes, very slight.
And in all of the examples you've just shown me, including the one with the moon, there were some artifacts in all of them. Can you identify some of them on this image for me?
Oh well, you can see there's no join between the there. For instance, you've got a white line above the horizon, and that's where you've got some extreme.
Sorry, just maybe I'm being stupid. On the Chicago skyline one, you showed that maybe 50% of the buildings were compressed, and now we're talking about a tenth of a millimeter.
That was more extreme than this. That was more extreme.
So the only example of the refraction is 1/10 of 1 millimeter at the base of the target object. Is that what you're saying? That's the only example to give us an indication that it's looming.
Well, no, I showed you looming effect. Well, this one.
Do you want to bring up looming again? Do you just bring up your picture?
Yeah, okay. I mean, this.
No, this one's not looming. Do you want to just bring up your looming?
Yes, there is a looming element to it. That's why I said the two effects. There's a looming effect and there's a compression effect.
Sure. Well, so as I say, what we can see in this image is obvious effects of refraction, Rumpus, in this image. So, for example, we have the obvious effect of this dome thing becoming square.
Well, actually, that's due to that. That actually is not. That's because of a light. That's because it's so bright.
I don't want you to explain it again, Rumpus. What I want you to do is identify something visually in the photograph of the Isle of Man that would give us some indication that this is actually what's occurring.
Well, when it's only slight refraction, then
Sorry, it's not slight though, isn't it? It's well beyond standard. We're into non-standard refraction.
No, it's not. I don't. No, I'll
now
show
you're
you
calling
that.
it slight.
Give me a chance. That was my next point. Is to how slight this. It's non-standard, but it's still, well within.
But regardless, as I say, in all of your examples, Rumpus, in all of your examples, there were some effects that were visually telling that we were experiencing refraction, even with the most small, which was the moon example you gave.
Okay, how about this
I had a close look at it, and you could definitely see, not this image, the one where you had them side by side.
But you just said all of his examples. That's one of his examples.
Well, in this flow chart or whatever you call it.
This is the one you were. Yes, this is the one you were most interested in, wasn't it? So this is more. So there's more refraction going on here, I believe, than in the one in the Isle of Man. So that's why it's slightly stretched. So here, for instance, you can't see any significant effects in terms of, you couldn't tell without knowing what the aspect ratio of these buildings were that there is a moderate amount of refraction.
But they are in fact stretched, correct?
They only, but you couldn't tell that because it's only by a factor of 20%. In fact, there's a marvelous video of this, which I was also going to play here, showing this actually moving up and down during the day by about 20%.
Okay, and is there any examples of that in the Isle of Man footage?
No, because this is more substantial. I believe the refraction for this image is more substantial than the one for the Isle of Man.
So, so far, all of the examples are more extreme than the Isle of Man example, even though there's a 1,200-foot wall that's being cleared by refraction.
Well, I'm going to show you the size of this wall. If that was my next point, actually, I was going to demonstrate exactly the size of, because your wall, I think I heard some mention of 1,000 feet, but that's only if you can see Douglas. You can't see Douglas, so that's an absolutely irrelevant example.
But it's the westerlymost tip. It's the westerlymost tip that we're talking about at 50 miles.
The westerlymost tip is here. I would. Where did I put it? I will show you. The westerlymost tip is here. This is that is the left. That's the left part of the picture. Here, it's to the right of Douglas. It's the big cliffs, just to the right of Douglas. I think it was 100 meters or something.
This is just a zoomed-in picture of a peninsula. It doesn't really give me any scale or reference, unfortunately. It doesn't really give me much help of referencing where we're looking at.
That's Douglas there. Sorry, okay. That is Douglas here. This is Douglas. I will. So I'll go back up to here then.
So just to sum this up though, Rumpus,
so
before you do this, sorry,
this,
Rumpus,
this
sorry, I just want to get to the end of my point. You had like 25 minutes. So what you're saying is that there is no real visual evidence in the picture to suggest that we are suffering the effects of non-standard refraction.
Well, it's only a little bit more than it is non-standard. It's a little bit more than standard.
No, that's not the bit. That's not the bit of the question I want you to address, Rumpus.
Okay.
The part of the question I'm saying is the visual evidence to suggest that we are experiencing refraction in the image. I've asked you to take me to it, and you've taken me to the very shoreline and said this 1 millimeter is the evidence of refraction. Is that it? Is that the only evidence? Is there any more?
Its position in the when you have moderate amounts of non-standard refraction, all that happens, you get looming. In other words, it lifts it up, as I demonstrated in the thing above. That's all that happens. When you have a moderate amount of non-standard refraction, all that happens is it lifts the image up. That's the only thing you can see about it. When it gets more extreme, you get more telltale signs of compression, distortions. But at the levels we're talking about, it's just all that happens is it gets lifted up. That's the only indicator.
So the bit where I'm a bit confused then is in one example you had part of the image, a tower, that we did have line of sight with, and part of the image which was suffering the effects of refraction. Well, we have the exact same thing going on in the Isle of Man footage in the respect. Hold on, I'm going to get muted.
Right, but this is
Hold on, I just want to get to the end of my rumpus. I just want to get to the end of my question. So in this example, you're saying that the tower, which we can't actually see the photograph of because your superimposed image is in front of you, but that's fine. You're saying that the part of the image that we do have direct line of sight with matches your superimposed image, whereas the stuff that we do not have direct line of sight with is suffering distortion. Well, in the Isle of Man image, we have the same exact principle. Part of the island we have direct line of sight with, and part of the island we do not.
Right, but it's all affected. Remember, what I've done, or it's all affected by, well, no, that's probably a bit unfair. As you go higher up, like, it's more graduated. Yes, the higher parts, yes, I can't draw an exact, but it's all refracted to a varying degree, but obviously only the most of the refraction is going to occur as you go towards the horizon. But it's actually, this is so low. I mean, it's so far away. I mean, it's 30 miles away.
So I'll ask it just one more time then, as you've just pretty much confirmed what I've said, which is that with direct line of sight we suffer no distortion, but without direct line of sight we do.
When you say direct line of sight, remember, when you talk about direct line of sight,
we can see it directly.
Curved. Even remember, when I said this direct line of sight, this happens. There's no such thing. Light does not travel in straight lines when you're looking through the horizon. None of it does.
Sorry, can I just... we've got a new guest called Banana. How you doing, Banana?
Hello.
This is what will happen to all light. Well, depending, as I said, there are sometimes it does travel in straight lines. That's when you get very special circumstances. It's unusual. Mostly, all light is bent.
What Nathan's actually trying to ask is, and what you need to understand, Nathan, is that even the things that shouldn't be hidden behind the curve, even those things still get lifted up slightly.
Yes.
Even those things are slightly lifted up. I think that's what Nathan is asking.
Yeah, I wasn't making that very clear. You're right. Well said, Paul. Yes, that's right. I did say it was all affected by refraction, but I didn't use a specific sentence. Yes, it's all lifted up. Yes, in proportion, uniformly lifted up.
So we have no way of telling.
That's right. That's right. You can't tell the difference. That's why it's not hard. You can't tell the difference between looking at something that's been lifted up by a few degrees and something that hasn't, except by the fact that it's been lifted up by a few degrees, because the effect is something I'll demonstrate why.
Okay, I will accept. If I accept that, so how do you prove that we are not looking at it directly if they look the same?
Because it's in the wrong position with respect to the horizon. Because we know...
Sorry, Rumpus, before you elaborate on that. So what you're saying is, based on the fact that you understand that we have a curved horizon curving away from us, you're saying that it necessitates it to be a mirage looming, what I call a holographic projection of the land that is obscured by the 1,200-foot wall of Earth curvature. That is necessitated... Hold on, I've just given Rumpus 20 minutes. I get 10 seconds.
Okay, all right, Nathan, go ahead.
Right, so that is necessitated by the fact that you are of the understanding that the horizon is curving away from us, therefore it has to be a refraction effect, correct?
well, yes, we know the Earth's curved and we know it's behind, but you can do calculation. We know from the physics, as I've demonstrated here, we know from the physics that it will curve. We can do measurements on the density
I understand
of the
that.
air,
You've just explained it
and
very
we can
concisely.
say, oh,
well,
what curvature should there be for the density of the air and the temperature gradient? You can do those measurements experimentally and say, we should expect this level of curvature, refraction of the air when you're looking horizontally. What would you expect? And that matches what we see. What we actually see, and you say, oh look, those two things match together. And the theoretical, the experimental, they come together. They both agree that light is always curved when you're looking horizontally.
I understand all that, but what I'm saying is that there is a necessity for it to be a mirage in the heliocentric model. And what what's a mirage Rumpus, mean? Why is it that I give you 20 minutes, nay 25 minutes to talk, yet that when we engage in a dialogue, you immediately cut off everything I say? Why is that?
Well, in reality,
it's just you don't understand what I've said. You see, you're repeating. If you understood what I said about the curving light, you wouldn't call this. You could call this a mirage, but all it means is that light is bent. If you want, and you're using the term mirage, which is usually meant to mean inverted image. Mirage actually technically means, in French, where it came from, an inverted image. All that happens is that light's very bent, and you talk about direct sight. Well, you have
okay, but what I'm trying to establish, Rumpus,
I've
listened to all this intently. What I'm trying to establish now is that if we have a direct line of sight with absolutely no curving light versus extreme refraction, or sorry, non-standard refraction that's minimal, while I get muted again.
Well, standard refraction.
No, bear with me, Rumpus. I'm battling against people muting me while I'm trying to get my point in.
Sorry,
Notice you had 25 minutes uninterrupted, right?
Yeah, that's bad.
So what I'm trying to establish is that we can see no visual difference between an entire island at varying degrees of curvature being raised up alongside its elevations that we have direct line of sight with also being raised up to the exact same degree. That looks no different to us just being able to see it.
That's right. We're very similar. There might be some small differences in the fact that the refraction will change gradually. So you might see, if you carefully analyze the picture, you might see a couple of percent difference between the scale being right or not, or perhaps 5%. It can vary. And obviously, when it gets to extreme, like the Toronto example,
could you do that? You've done such a good job, Rumpus. Hold on. You've just hold on, Paul. Paul, I'm nearly at the end of my conversation with Rumpus. Nearly. So, Rumpus, as you have said now that there is, chances are, effects that could be measured if it was being refracted, albeit minor. Could you perhaps search for those effects and then demonstrate them for us?
Well, I'd say they're very minor. I mean, I'd have to really struggle to find them. They're going to be 1% difference.
Well, if there's no difference between us having direct line of sight and it being refracted, and the only thing that can prove it one way or the other are these very minor details, I would expect you to find them to prove it is a mirage.
The image is not of a good enough quality for me to do that.
What a shame.
I can barely identify houses on it. And if
what a shame.
You're talking about me identifying.
So we cannot prove either way if it is a mirage or not.
Well, the image is not.
I just want to ask. I want to get an answer to this question. Can we definitively prove whether or not it is a mirage?
Without Anthony's.
I haven't asked you anything, Tony. There's no need to interrupt Rumpus. He's just done a presentation. I'm just asking him a few questions.
If you had a very good quality image, you could do it. We do not have a sufficiently good quality to identify the difference here between a diorama. All we're talking about is where the lines are very straight, exactly straight to you, or very, very slightly bent. That's the only difference between what you're calling a mirage and the direct line of sight. They're and I will demonstrate in this next bit how close those are, and then you'll be able to see, oh, look, they're so similar, I wouldn't be able to tell the difference.
Okay, so again, I'll just clarify it. What we have is a situation where we cannot tell the difference between something that is being miraged up above an obstruction and something we have direct line of sight with, according to you.
With the quality of those images, yes, it's been.
Well, that's what we're dealing with, Rumpus. We're dealing with those images.
Well, I think they're not good enough for you to do that.
So they're not good enough for us to determine whether or not we are looking at a mirage.
Obviously I can't tell that absolute fact, but I would say probably it's I would say that was next to impossible. I mean, I'm not sure, but I suspect that the quality that because you're talking about 1 or 2% differences in sizes of things, and the quality of the image is just not up to it.
Okay, thank you, Rumpus. We've been joined by Sleeping Warrior. Good to have you here, Sleeping Warrior.
So I was going to get to the point to demonstrate the scale of the issue, which is
all right. I think you've had long enough, Rumpus. No offense, but you've had like 25 minutes of the show.
I agree. Okay, well, I've got quite a critical point here. Hopefully, I could do very quickly. Perhaps if I just make the punchline. But if you don't want me to, I won't.
And Rumpus, wouldn't the barometric pressure would have helped you in your scaling?
Well,
Rumpus, ignore everything Nathan says.
Right. I can quickly demonstrate. This is the scale of the situation. This is a scale model. I'm going to just actually scale to show how much bending is actually going on in the real world. Actually show you to scale how much bending is going on. I can show you that. First of all, I just wanted to show you a scale model of the Earth with St. Bees, and I've put here St. Bees at one end and Douglas at the other. But we can't see Douglas, but I've just put it there anyway. That's how far they're apart. They're 68.4 kilometers apart. And that represents 0.61 degrees of angle. So that's what it looks like with regard to the Earth. That's to scale. This is a scale model. So that's the 0.8 degrees separated, and that's 68. That's what 68.4 kilometers looks like on the full scale of the Earth. And I've got the coordinates there. So let's zoom into that. Let's just see what that looks like. So now I've got a scale view of the actual view. Now you might say, so here we have to scale. Here I've got St. Bees up here. Point here is St. Bees. And down here, I've got Douglas. Again, we can't see Douglas. The closest one we can actually is the left-hand edge on the picture is here. So along here is distance. So that represents 68 from this point here to that point there, 68.4 kilometers. And that's what the Earth curve looks like at this scale. That is that's the level. You might say, well, that's just a straight line. Okay, let's investigate. And you can see here, what I've done is I've joined this red line here is the surface of the Earth at Douglas joined to the surface of the Earth at St. Bees. So if you go up here, I move along, you can see the red line is moving closer and closer to the surface of the Earth, and then you can see, right, so that red line, if I zoom in there.
Just before you do, I just want to say a quick hello to, is it Flowbirth? How you doing, Flowbirth?
Good evening, Mr. Bond.
Good evening.
So this is St. Bees. I was going to actually put in the cliff face in here that Anthony was on, which I believe I was looking. I've only just started researching. It does look it's at least 75 feet above water level.
35. 35.
No, it's not. No, it's not.
That's what it says. 35.
I know that's what I know. You haven't. Also, you haven't allowed for the tide, which is at least 5 meters.
I've been getting kicked all night. This is my third attempt. All right.
Anyway, so we'll deal with that in a minute. Anyway, so you can see here, this is what the difference. That is the difference between a straight line and the curve of the Earth. And I haven't. And these are the points. And you can see here again. That is to scale. So that's how bendy the Earth is. And I was going to draw in the little heights of the things on here and then draw their individual lines. This is going to ground level. So that I've only drawn one line in from Douglas here. Oh, there we are. So there's Douglas there. You can see, so it only requires the very, very tiniest, and that to get around that curve, you can see that the bending has to be so tiny. And this idea of a standard refraction, there's actually no standard. There are various ideas of what a standard refraction is. And the curve required to move across that line, as you can see, compared to what I was showing you earlier, is very slight. That's the scale of the issue. And I've drawn in all these positions here, and I was going to do the calculations on and they're all missing, it seems to me, but I did a calculation.
Okay, Royal Rumpus has total and utter verbal diarrhea. I'm going to do a few plugs. So, if you are new to this channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a link to Super Chat alongside the show while it is live. And if you would like to join the debate with the page you are currently watching on mute, simply click the link in the info box below this video to join the show and express your views on the shape of the Earth. If you have not done so already, please share the show, as it does increase the live audience, which in turn increases the chances of a more diverse panel. And one more time, if you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. We have around 15 minutes left on this live stream.
He claims to do the reverse, which is a complete piece of idiocy.
Hey man, how you going?
So I think that's possible. I can probably stop there, Nathan. Yes, I've
Jolly good. Thank you, Rumpus. Excellent presentation.
That was a good job.
Excellent job, Rumpus. Excellent job.
Thank you very much. I haven't done it. I haven't finished it. I haven't done all the. I was going to put in all the angles for all the different observation points, and I can identify any point in the picture that Anthony's done. And also, of course, I've validated that 3D model that Anthony got.
You've been muted by a sniper, Rumpus.
But anyway, I'd just like to say again, I know I keep banging this home and I still will, but you don't see, you're claiming you can't see any effects of refraction, but we can't see any effects of the Earth being flat either.
They look exactly the same. We've just established that.
No,
Alex.
they don't. We can't see the beach. Can't see Douglas. That's what I've seen. That's what Rumpus has just been
So he
established.
claims.
Well, that's what he claims.
Put it on this.
He's made. He's got evidence for
about
it.
the because I've identified all the blobs in there, and I've seen if my image is correct. And I've matched it against the picture, against things on Google Earth, and they match up exactly. So unlike the guy who did that 3D thing, I've actually checked my image and all the heading, well, not all of them, but I mean a good few of them, to make sure they match up against Google Earth and the headings are right. So I know that where that left-hand edge that we see in the picture is not Douglas, but it's to those cliffs at 100 meters high to the right of Douglas. So I know exactly where that, and it's not in that. And obviously, this guy who's doing that 3D model, he just simply stretched it, accepted that composite as is. He's no idea whether it's correct or not. He didn't check it. So he's no idea. He also didn't know where to put it exactly. He doesn't know what zoom Anthony used. So he could have put it, if he put it further back or further forward, it would have changed it. He doesn't know the composition of the thing correct, whereas I've checked mine, and I've also checked mine empirically against Google Earth, and I've actually focused in on white blobs and identified exactly what they are. So I know that my headings and my calculations are correct. I've matched it against reality.
Rumpus, I've got a couple of questions for you.
Okay, fine.
Nathan, would you mind sharing my screen on Skype?
Yeah, give me a second.
Sure. I'd have done it in the chat, but unfortunately I got sniped, so...
Yeah, there are a lot of snipers out there today. Maybe we could make a format where that's not possible. I don't know. Maybe that would make for a better debate.
Well, the intention is to disrupt as much as possible, isn't it? So they don't want the debate.
There you go.
Well, this isn't a debate to begin with, but all right.
Thanks for being here, by the way, Lou. Thanks for your support.
Oh, no problem, Nathan. Thanks so much for having all of us here.
Pleasure.
Stay up to date with the flat Earth debate.
Hey, Mars, don't talk. You're bad at life. You're a disgusting person.
Oh, come on, let's be friends.
All right, Rumpus. I didn't listen to the main part of your presentation because I found it really quite dull. And I don't mean that as a bad thing. I mean it as a fair comment.
I understand it's very
doesn't mean he's wrong,
Anthony. When you don't understand what a sine function is in trigonometry, I understand a lot of geometry there, and maths is going to confuse the hell out of me.
How did you deal with light bending up, Rumpus, in your presentation?
You trying to? So I missed that. You trying to show me something?
I'm asking you, how did you deal with light that bends up? Because according to Fermat's principle, light will bend up, down, left, and right at all times, and we see that evidence in the image that I'm showing on screen. Summer sound.
Oh, really? Is that what Fermat's principle predicts?
Is that? Well, the situation we're dealing with here is this one where we've got a graduation density.
I understand, but I'm asking you specifically, how did you deal with light that bends up in your demonstration?
Is that what's happening in this picture you've got shared right now? Because that's not what it looks like.
Well,
perhaps you should watch carefully.
I'm dealing with this situation which is close to the standard atmosphere at the moment, with a slight bit of extra bump. And
right,
but if
so you didn't address light bending up.
You get inverted
So do we agree that
gradients,
light bends up as well as down, or not?
Yeah, well, obviously it goes up and down, depending on what the temperature gradient is and the pressure, the density gradient.
Okay, so would it be the case that in this example that we're looking at with the Isle of Man, is it the case that the light must be bending down because it makes it? Oh no, hang on. Which way would it go for, on your explanation? Would you argue that the light must be bending up, making it look flat?
Which means you normally get looming, which means you normally have it when you look horizontally. Normally, you'll be able to see over the horizon. So things are lifted up in effect. Most of the time, things are lifted up.
So your position is that the light must therefore be lifted up because of the bending of light is lifting up in your presentation. Then in your position, is that right?
Atmospheric conditions, that's what will happen. Yes.
Okay. How would we know whether the light's bending up or down or not?
Well, you can see, you know the radius of the Earth, and you can say, oh look, I can see that slightly up, and if it's only slight, the only differences
do you mean the apparent
lifting
radius
up,
of the Earth?
and of course, the maths, the physics tells you that's what will happen. You compare that against reality and say, oh look, the horizon should be there, that's slightly up. Yes, the maths and what you see empirically matches. Oh, that's good. There we go, sorted.
Did you misspeak then? It was you said it was the radius of the Earth, but isn't it the apparent radius of the Earth that we can do all these measurements against?
No. What that apparent radius was put in there into the maths, you use the radius value, but the maths, the 7/6R, is just a factor you can shove in. It's not changing the radius of the Earth, but the maths makes it look like it is. You haven't changed the radius of the Earth. It's just something you use for the curvature in my example. It just the rate, because it's curving, you can use the equation by shoving a different value of R, and it gets the same effect. It just so happens that you can do that with
let's try and keep the answers concise so that I can stay on point without being distracted.
All right, I got
don't say sorry to him. Hey, Rumpus, don't say sorry to him, okay?
I've got a very
Would you
concise
agree
answer
it is
for you,
an apparent
Anthony,
radius
and it's that
or not?
last
Is it an
image that
actual
you
radius
had.
or
You
is
had
it
a
an
series of
apparent
images from one of Soundly's videos up, and that demonstrates the variation in refraction. It's very well.
Exactly.
It's amazing. You were looking right at it.
Yeah,
I agree with Lewis. That demonstrates the refraction perfectly. Light bends up as well as bends down.
It shows it going up and down, but you still see curvature in every single image.
Well, how do you know? No, not in every single image, because how could you argue that you see curvature when the light is bending up, Lewis?
It is bending up, but not enough to make it look flat, and not enough to make it look like an inverted curve.
You can actually get certain conditions, as I mentioned. Obviously, Anthony missed this, or he's bored, fell asleep, or couldn't understand. There were examples where, in fact, you do the light. You can actually get the light, and the certain conditions to actually go around the whole Earth, keeping the same height above the Earth. So, in fact, it would look flat. You could almost see round the other side of the Earth if you could resolve it. And there was no interference, and obviously deterioration in the quality thing. You could actually get a light beam to go all the way around the Earth, so you could actually see your own
I believe
bottom.
Paul has the same view, and I find that literally hilarious.
I'd like to point out to Lewis that this model
Shit, people are gonna be PMARs. No.
He thinks that life is just flat Earth.
And obviously, in the second that I described, it looks like the Earth
seems to be an obsessive individual.
Well, I think you're a moron. So that's
has this got anything to do with Anthony's question? I think Anthony's in the process of trying to debunk something here, isn't he?
No, I'm just asking specifically, how did you deal with the light that bends up? Because obviously once the light starts to bend up, it then has to catch up an awful lot to start catching back up to the point that it was previously on when it wasn't bending up.
That's the most non-scientific gibberish I've ever heard. Yeah. It has to catch up. What on earth are you
so
talking about?
Basically, your position is that light that bends up is gibberish. Is that the position?
No, I didn't say that, but I said the sentence you put in was gibberish.
Yeah, but the minute it starts to bend away from the curve that you think that it's following, it then has to catch up at some point. So it has to bend double what it was previously. So that becomes crazy.
Like a single beam of light, a single ray, a single photon of light isn't like that. That isn't all of an image. Like you have trillions of photons in an image. So I mean,
And they don't try and catch up with one another. They just do their own thing. They don't try and catch up with one another. There's no catching up.
But it would have to, wouldn't it? Otherwise, it would just bend off into space eventually.
Yeah,
I would like to know.
Some of them do end up in space.
But when we look at any horizon, we never see reflections of space, do we? We only ever see land.
Douglas and all the coordinates, because you were pretty much wrong about all of them. Rumpus just showed us all the right places, so.
Yeah, I know he showed us all the coordinates and whatever, but I'm asking about the light. How did you deal with the light in your presentation?
This whole time,
did you deal with light bending up or not, Rumpus?
Right, but Anthony did initiate that. We're dealing with Anthony's questions here, aren't we? So we should focus on what he wants here, I think.
Really?
Did you deal with light bending up?
Yeah, but you remember your question, Tony, and then you come back with that. But I mean, he's in the middle of trying to make a point here, so let's deal with it.
Did you deal with or address light that bends up, Rumpus? Straightforward question.
But no, because that's not what's happening in this situation. Why should I deal with a situation that's not happening? I'm dealing with the standard or near standard situation. We're dealing with the Isle of Man in this example.
No further questions.
So I'm dealing with
Thank you very
standard
much,
atmosphere,
Rumpus.
and I'm trying to allow for that.
No further questions. Thank you very much, Rumpus.
Thank you, Your Honor. No further questions.
Yeah. Okay, now can you ask why? Did you guys purposely deceive us with Douglas, you, Chris, and Ranty? and all the other coordinates, or where you guys just messed that up?
Well, they got the pictures wrong, didn't they? They miscomposed
I
the
know,
pictures.
that's why I want the answer. I want the answer. Like, was this all coordinated? Because it seems like it's coordinated. Because a lot of things have been wrong.
Incompetence can have many manifestations.
What was the question?
You knew the question.
No, I missed the first 4 or 5 words. Ask me the question concisely, and I'll give you a concise answer.
Did you purposely deceive us about Douglas and the lighthouse? The what was that? The ferry being the lighthouse?
Douglas and the lighthouse. You do realise that Douglas and the lighthouse at the opposite end of the island.
All mess ups, or
keep it simple, Tony. Riley, did you purposefully use deception in one way or another with your images from St. Bees?
Right. No, is the answer to the question. And I would like to know where the deception claim comes from. Because the lighthouse and Douglas are nowhere near each other.
What you say can and will be held against you.
Absolutely, but can you tell me what the deception element is? Because I'm not familiar with where there's any deception apparent, let alone actually.
Oh, don't you worry. It'll come. It'll come. Don't you worry. All things come to those who wait.
It's going to come. Never mind.
So is the issue to do with the lighthouse or to do with Douglas?
They know what they did.
Everything, man. Everything. But don't worry. We'll get there.
What I would love to see actually is the image.
If your analysis involves me standing on a golf course or using a Girl Guides map, I'm not that worried about your analysis, to be honest.
You know, it doesn't matter if you're worried.
Well, if you think I was stood on a golf course or you compare it to a Girl Guides thing, then I'm not that bothered about it. It's kind of
not the Girl Guides.
If you've got anything critical that's obviously like credible, bring it, because we're here to try and establish the facts. But if you're going to try and do it from the view that, oh, well, you must have lied to us,
Anthony, everybody already knows.
Then put me in a golf course and then use a Girl Guide map to say that I was in the wrong height.
If your criticism was, hey, Google Earth is not accurate with elevations, then we would have no disagreement. But that's not what you do. Okay.
No, but you don't understand. I'm applying your model, so I don't care whether it's accurate or not.
I just would like to speak. You asked if I had anything critical to say. I do. Here it is. I have something critical to say. It's right here.
Yeah. Well, again, I repeat my position.
Anthony, what are you doing? Literally, when I get done saying that I'm going to say something, you start talking. All right. Now, the issue is that we do not think that Google Earth is an accurate representation of the elevations on Earth. We don't think that, and you're pretending as if we do.
Your model. You can't go against your own model.
That is potentially dishonest. That's potentially dishonest, especially since we've told you so many times that we don't think Google Earth is an accurate representation of the elevations.
All right, listen, I'm going to conclude. I'm going to wrap up by just making this point for a second and final time. In the wonderful observation and presentation that Rumpus did, he didn't address the light that bends up at any point. Speaks volumes. Thank you and good night.
That's going to be the end of our show, folks. So with that, I'm going to say first and foremost a huge, massive, enormous thank you to all of the live audience for tuning in and for sharing this debate. And also a massive thank you to all of the debating panel for making this debate possible. Be sure to like, comment, share and subscribe. I've been Nathan Oakley and I'll see you all in the next video.